Hello everyone. Today is 14th of November, a day which is celebrated as Children's Day. So wishing you all a happy Children's Day. Today we'll be doing the ninth chapter of class ninth maths, that is areas of parallelograms and triangles. So let's understand what area is. Suppose there is a plane is there. This is a plane. In this plane, there is a closed figure is there. So area of this closed figure will be part of the plane which is enclosed by the figure. Whatsoever the part of this plane is enclosed by this figure will be the area of this figure. Suppose I am taking this as the figure, then the part of the plane which is enclosed by this figure will be the area of the figure. So area of the figure is having any numerical value with any of the unit. So the numerical value with any of the unit which shows the part of the plane which is enclosed by the figure is known as your area. We have learned about congruency of any two figures. Suppose we are having any two circles with the same radius. If there are two circles, suppose the radius of these two circles is your 5 centimeter. So if there are two circles with the same radius, we will say that these two figures are your congruent figures. That means if we are going to overlap each other, they are going to overlap each other. If we will be keeping one over the other, they are going to exactly overlap each other. Similarly, if we are going to take two triangles which are congruent, then what does it mean? If we are going to keep one over the other, they will be exactly overlapping each other. And because they are exactly overlapping each other, that's the reason they are known as your congruent figures. And these congruent figures will be having the same areas also. Why? Because if we are keeping one over the other, they are exactly overlapping each other. That means the part of the plane which is enclosed by both of them will be same. That means area of the congruent figure is always same. Suppose this is your A figure. So area of the figure will be represented as area of A. If this is your B, so area of this will be represented as ARB. This is how we represent area of any of the figure. If its name is either A or B, then we can represent this way the area of these figures. And just now we have said that area of congruent figures is same. Now suppose if in a plane, suppose I am going to say that there are two figures are there, like these two are the figures. This is your A figure, this is your B figure, and they are not overlapping each other. This figure A is not overlapping the figure B. And overall this is your figure S. Then the area of this S will be sum of area of this A plus sum of area of your this B. That means area of S will be area of A plus area of B, because they are known overlapping figures. If these two figures are known overlapping, then the combination of these two, that is your S, area of S will be area of A plus area of B. This is how we can represent the area of this figure. Now what area is basically? Area of a figure is a number in some unit associated with the part of the plane enclosed by the figure with following properties. If A and B are two congruent figures, then area of A will be equivalent to area of B. Just now we have discussed that for congruent figures, the areas are equal. If a planar region formed by a figure S, suppose this is a S, is made up of two non-overlapping plane regions. This is formed by your two non-overlapping plane regions formed by the figures A and B. Then area of S will be area of A plus area of B. This is the properties of your area. We have learned about area of a rectangle. We have learned about area of circle. Some of the figures we have already learned how to find the area. So let's recall it. Area of rectangle, we know it is your length into width. If this is a rectangle with whose length is L and width is your B, so area will be your L into B. Similarly, area of a circle, it is your pi r square. Area of square, if its side is A, then it is your A square, or we can say square of the side will be the area of the square. Now in this chapter we will be learning about area of triangle also and area of parallelogram also. Now if two of the figures are given to us, how we can say that the two given figures are on the same base or not? For understanding this, let's have some examples. Suppose there are two figures, that is ABCD is one of the trapezium and AEFD is one of the parallelogram. If these two parallelogram and your trapezium is having a common side, they both are having, over here we can see the parallelogram AEFD and the trapezium ABCD. Both are having a common side, that is AD is common for both the two figures. So we will say that these two figures are on the same base. Similarly, we will be taking two parallelograms. One is your ABCD, another is your AEFD. They both are having a common side, that is your AD. For the parallelogram ABCD also AD is there. For the parallelogram AEFD also AD is there. So if a side is common for both the two figures, we say that the figures are on the same base. Similarly, we will be taking two triangles. One is your ABC, another is your APC. These two triangles are having a common side, that is AC. So we will be saying that these two triangles are having the same side, that is they are on the same base. If we will be taking one of the parallelogram and one of the triangle, that is parallelogram is your ABCD and triangle is your APD. They both are having a common side, that is AD. So we will be saying that both the parallelogram and the triangle are on the same base. So this is how, if any of the two figures are having a common side, then we will be saying that the figures are on the same base. Now when we will be saying the two figures are on the same base also and between the same parallels also. So if there are two figures are there, one of the parallelogram is there ABCD, another is your trapezium AEFD. These two figures are on the same base AD. They are having a common side. That common side is your AD. That means they both are on the same base AD. Now the opposite vertices, AD is the common base for both of them. So opposite vertices for the parallelogram ABCD is your BC. And for the trapezium AEFD, the opposite vertices are your E and F. So if the opposite vertices of both the figures lie on a straight line, all these four lie on the straight line which is parallel to the base, and the line should be parallel to the base, then we say that the two given figures are on the same base and between the same parallels. Similarly, if there are two parallelograms are there, one is your ABCD, another is your AEFD. So over here, the parallelogram ABCD for this AD is the common side and your AEFD, for both of them AD is common. So both are on the same base AD, and the opposite vertices of ABCD are your B and C, and the opposite vertices for the parallelogram AEFD is your E and F. They all are lying on a straight line and this line is parallel to your base AD. That's the reason they will be on the same base and between the same parallels. Now if we will take example of two triangles, one of the triangle is your ABC, another triangle is your ADC. These two triangles are having a common side, that is your AC. That means both the triangles are on the same base AC. And the opposite vertices for the triangle ABC is your B, and the opposite vertices for the triangle ADC is your D. Both the two vertices lie on a straight line which is parallel to the base AC. That's the reason both the triangles ABC and ADC are on the same base and between the same parallels. Now take one more example. We have taken one of the parallelogram and one of the triangle. Parallelogram is your ABCD, it is having a side AD, and the triangle is your APD, which is even having a side AD. That means they both are on the same base AD. And the opposite vertices for the parallelogram are your B and C, and the opposite vertices for your triangle is your P. All these three are lying on a straight line and this line is parallel to your base AD. That's the reason we will be saying that the triangle and parallelogram are on the same base and between the same parallels. So how we will say that the two figures are on the same base and between the same parallels? So two figures are said to be on the same base and between the same parallels if they have a common base. That means if they are having a common side and the vertices or the vertex opposite to the common base of each figure lie on a line parallel to the base. That means opposite vertices for both the figures should be on a line and the line should be parallel to your base. If this is the condition, we say that the figures are on the same base and between the same parallels. Now let's see some more examples over here. Suppose this is your A, this is B, this is C, this is D and this is E. Now we can see one of the triangle is your ABC, another triangle is your ADE. For the triangle ABC, base is your AC, and for the triangle ADE, base is your AE. For both the two triangles, base is not same. So it is not on the same base. Although it is on the same parallel, between the same parallels, it is a parallel line. It is even both the two lines BD and AE are parallel lines. So both of them lie between the same parallels, but they are not having the same base. Similarly, if we are considering this figure, suppose this is A, B, C, D, E, F, G. The parallelogram is your ABCD and your triangle is your EFG. They both are between the same parallels AD and BC, but their base is not same. For the triangle, your base is EG, and for the parallelogram, your base is AD. That's the reason they are not fulfilling these conditions. So now let's understand some of the questions from your exercise 9.1. Question number 1. Which of the following figures lie on the same base and between the same parallels? In each case, write the common base and two parallels. So first part we are considering. The figure is like this. This is your A, B, C, D, and it is your P. So over here we can see one of the trapezium is there, that is ABCD is a trapezium, and your triangle is there, DPC is a triangle. They both are having the same base, your DC, and they both lie between the same parallels. AB is even a parallel line, APB are on the same line which is parallel to the base. So over here base will be your common base is your DC. DC is the common base and parallel lines are your between which parallel lines they are? Between AB and DC. They are lying between AB and DC. Now let's take the second example, second question. The figure is like this. This is your P, Q, R, S. This is your M and N. See both the two figures. One is your PQRS, another is your SMNR. These two are having the same base SR, but they are not between the same parallels because the opposite sides of your opposite vertices of your trapezium SMNR, this is your M and N, are the opposite vertices, and for the parallelogram opposite vertices are your P and Q. They four are not lying on a straight line. So that's the reason they are not between the same parallels. So it is not the true condition. The third is your figure. This is the figure. From here a triangle is there. This point is your P, Q, R, S and T. So this figure, in this figure there is one of the triangle is there and one of the parallelogram is there. So they both are on the same base and between the same parallels. We can see the triangle is even having QR as the base and the parallelogram is even having QR as the base. So common base is your QR and they are between the same parallels. Parallels are your QR and PS. Opposite vertices of QR is your PS are the opposite vertices for the parallelogram, and for the triangle opposite vertice is your T. All these three lie on a straight line which is parallel to your base QR. So it is fulfilling the condition. It is on the same base and between the same parallels. This is how we can find it out whether the given figures are on the same base and between the same parallels or not. Now let's understand if there are two parallelograms on the same base and between the same parallels, how we can prove that their areas will even be equal. So suppose we are having two parallelograms. We are having one is your ABCD and another is your EFCD. These two parallelograms are having a common side, that is your CD. That means both the parallelograms are on the same base CD. And the opposite vertices of the parallelogram ABCD, that is your A and B, and the opposite vertices of your EFCD, that is your E and F. All these four vertices are lying on the same line, which is parallel to your CD, which is parallel to the base. So we will be saying that these two parallelograms are on the same base and between the same parallels. Now what is given to us is that parallelogram on the same base and between the same parallels are equal in area. This is your theorem 9.1, that if there are two parallelograms on the same base and between the same parallel lines, then the area of both the two parallelograms will be equal. Now how we can prove it? Given to us is that there are two parallelograms there. One is your ABCD, another is your DEFC. They are having the same base DC and they are between the same parallels DC and your AF. It is given to us. We have to prove that area of ABCD is equivalent to area of your DEFC. This we need to prove. Now over here what we will be doing is we will be considering the triangles AED and triangle BFC. These two triangles we will be considering. In these two triangles we can see that AD will be equivalent to your BC because they are opposite sides of the parallelogram ABCD. For the parallelogram ABCD, AD and BC are the opposite sides. That's the reason AD will be equivalent to BC because they are the opposite sides of the parallelogram. We know that in a parallelogram opposite sides are equal. Now again if we will be considering the AD and BC, they will be parallel to each other because the opposite sides of a parallelogram are parallel even. So AD and BC are parallel and this AF is the transversal. So we can see angle 1 and angle 2 will be equal because they are your corresponding angles. For the line AD and BC, which are parallel because they are the opposite sides of a parallelogram. So if these two are parallel and this AF is the transversal, so angle 1 will be equivalent to angle 2, reason being they are the corresponding angles. Now if we will be considering the parallelogram DEFC, in this ED will be parallel to your FC because they are the opposite sides of the parallelogram, and in that case your angle 3 will be equivalent to angle 4 because they are even the corresponding angles. So for the parallelogram EFCD, ED is parallel to FC. That's the reason angle 3 will be equivalent to angle 4. They are your corresponding angles. Now in these two triangles, angle 1 is equal to angle 2, angle 3 is equivalent to angle 4 and AD is equivalent to your BC. So we can say that these two triangles are congruent by your AAS congruency rule. These two triangles will be congruent to each other. And just now we have said that if two triangles or the two figures are congruent, then their areas are also equal. That's the reason because they are congruent. So area of AED, triangle AED will be equivalent to area of triangle BFC. Now what we have to find is we have to prove that area of parallelogram ABCD is equivalent to area of parallelogram EFCD. This we need to prove. So we will be taking area of parallelogram ABCD. So area of the parallelogram ABCD could be written as area of triangle AED plus area of EBCD. If we will be adding the area of this your part, that is your triangle AED, and your this part, that is your area of EBCD, we will be getting area of parallelogram EBCD because they are known overlapping figures, and if we will be combining these two, we will be getting the area of this parallelogram. So area of parallelogram ABCD will be area of triangle AED plus area of EBCD. This will be, if we will be adding, we will be getting area of parallelogram ABCD. Now just now we have said that area of AED, triangle AED is equivalent to area of triangle BFC. So instead of AED, we can write area of triangle BFC also. So we have written area of triangle BFC plus this we have written as it is area of EBCD. Now see, if we will be taking area of EBCD, this area, plus area of BFC, this area of this triangle BFC, we will be getting area of the parallelogram EFCD. So this could be written as area of parallelogram DEFC, and that was only to be proved that area of parallelogram ABCD is equivalent to area of parallelogram DEFC. So this is how we can prove that if there are two parallelograms on the same base and between the same parallels, then their area will be equal. Now let's understand what will be the area of a parallelogram and what will be the area of a triangle. See, if we are going to take two parallelograms, one is your ABCD, another is your DEFC. One of the parallelogram is your rectangle and another we have taken a parallelogram, only simple parallelogram we have taken. If these two parallelograms are on the same base DC and between the same parallels your DC and AF, in that case area of these two parallelograms will be equal. Just now we have said that if there are two parallelograms on the same base and between the same parallels, then the area of these two parallelograms will be equal. Now over here one of the parallelogram is your rectangle. That means area of ABCD, which is a rectangle, will be equivalent to area of DEFC. And we know that the area of a rectangle is your L into B. That is your, this is your base and this is your L, this is your B. So area of rectangle ABCD, we know that it is equivalent to your L into B. L will be over here your DC and B will be your AD. This will be your length and width of the rectangle ABCD. Now if we have drawn a perpendicular or the altitude from the vertex E of the parallelogram DEFC, so we have drawn a altitude, that is your EG, on the base, that is your DC. So this EG will be equivalent to your AD also, right? Why? Because they are between the same parallels and the perpendicular distance between the same parallels remain same only. That's the reason your AD will be equivalent to your EG, because both of them are making an angle of 90 degree. They are the perpendiculars between the same parallels, and the perpendicular between the same parallels will be your same only. So your, it could be written as DC multiplied by your EG also. Right? Now DC is the base for your parallelogram EFCD also. That means we can say that area of parallelogram DEFC, because area of ABCD, that is rectangle ABCD, is equivalent to area of your DEFC parallelogram. So area of DEFC will be DC multiplied by your EG, where DC is the side of a parallelogram and it is your corresponding altitude of the parallelogram. That means area of the parallelogram is side multiplied by corresponding altitude. If we will be considering this as the side, so we will be taking this as the altitude. If we will be considering this as the side, then from here we will be making an altitude. So the area of parallelogram is your, either you can say base into height, or you can say any of the side you will be taking and corresponding altitude you will be taking. This is the formula for finding area of a parallelogram. Now if we will be considering a parallelogram and a triangle with the same base and between the same parallels. Suppose we have taken ABCD is a parallelogram and APD is a triangle. Now these two triangle and the parallelogram are on the same base AD and between the same parallels your AD and PC. Between these two only, these two, your parallelogram and triangle both are lying. Just now we have said that the area of the parallelogram is your side into corresponding altitude. Just now we have said. Now over here we know that the area of your ABCD, that is your parallelogram, what it could be written as your, it could be written as your base into height either, or it could be written as one of the side multiplied by corresponding altitude. Just now we have seen. Now what we have to find is, we have to find the area of the triangle. For that, what we will be doing is, first of all, construction we will be doing. We will be making a line from your D, from the point D, which will be parallel to your AP. A line we will be making from the point D, which will be parallel to your AP. So we will be making a line which is going to intersect this line PC at point Q. Now, because this is parallel to your this line and automatically AD is parallel to your PQ, so APQD will be the parallelogram. Again, here we can see ABCD was automatically, we had taken a parallelogram, and earlier we had taken a triangle APD, but now what we had done is we have drawn a line parallel to the AP and joined it. It is your DQ. So APQD will even be a parallelogram on the same base AD and between the same parallels AD and your PC. We had already seen that if there are two parallelograms are there and which are on the same base and between the same parallels, then their areas are equal. That means area of ABCD will be equivalent to area of your AP, Q and D. Both the two parallelograms are on the same base and between the same parallels. That's the reason their area will be equal. Now, PD is the diagonal of the parallelogram APQD. For the parallelogram APQD, PD is the diagonal, and we have learned in the chapter quadrilaterals that the diagonal of a parallelogram divides it into two congruent triangles. Diagonal of a parallelogram divides it into two congruent triangles. So one of the triangle is your APD and another triangle is your PQD. These two triangles, PD is the diagonal. So area of triangle PAD will be equivalent to area of triangle PQD. Because if the triangles are congruent, we know that the two figures which are congruent to each other, their areas are even equal. So because these two triangles, triangle PAD is congruent to triangle PQD. These two triangles are congruent because the diagonal divides the parallelogram into two congruent triangles. That's the reason area of these two triangles will even be equal. Now, area of parallelogram APQD could be written as area of PAD plus area of PQD. This APQD, it is a parallelogram. If we are going to add area of this triangle and area of this triangle, then we will be getting area of PQDA. So area of APQD will be equivalent to area of PAD plus your PQD. If we will be adding areas of these two triangles, we will be getting area of your parallelogram APQD. So area of APQD is equivalent to area of PAD plus we can write area of PAD only because both the areas are equal. So instead of PQD we can write PAD also. So area of APQD is equivalent to 2 times of area of PAD, or we can say area of APQD half of area of PAD. Area of PAD, area of the triangle PAD will be half of area of APQD, right? And area of APQD was equivalent to your area of ABCD. ABCD, it was the parallelogram. So we can say area of PAD will be half of area of your ABCD. Right? So what we concluded is that if there are two figures are there, one is your triangle, another is your parallelogram on the same base and between the same parallels, then area of triangle will be half of area of the parallelogram. This is how we can prove it, that area of triangle will be half of area of parallelogram if they are on the same base and between the same parallels. Now just now we said that the area of the parallelogram is base into height. right? If whatsoever the base we will be taking, accordingly corresponding height we will be taking. So we can say that the area of triangle is 1 upon 2 into base into height, or whatsoever the side we will be taking as the base, accordingly corresponding altitude we can say 1 upon 2 into any of the side we will be taking and corresponding altitude. That will be the area of your triangle. This is how we can find it out, that area of parallelogram is side into corresponding altitude and area of triangle is half into side into corresponding altitude. So we can say that if there are two parallelograms are there on the same base between the same parallels, their area will be equal. If there are two figures are there, one is your parallelogram, another is your triangle, in that case area of the triangle will be half of the area of the parallelogram. Till now we have seen that the part of the plane which is enclosed by a closed figure shows its area, and if there are any two congruent figures are there, then their areas will be equal, although it is not compulsory that if the areas are equal then the figures will even be a congruent. That even we can see, as we are saying that the two figures, if they are congruent, their area will be equal. But if we are having a square with the side 4 and we are having a rectangle with the side 8 and 2 centimeter we have taken, 4 centimeter we have taken. So area of the square will be side into side, that is 4 into 4, 16 centimeter is square, and area of rectangle will be your 8 into 2, that is your 16 centimeter is square. Over here areas are equal but the figures are not congruent. So if figures are congruent, their area will be equal, but it is not compulsory that if areas are equal then the figures will be congruent. Along with that, we have seen that the two figures, if they are on the same base and between the same parallels, and if they are parallelograms, then their areas will be equal. If there are two parallelograms are there which are on the same base and between the same parallels, then their area will be equal, and the area will be equivalent to your base into height, or we can say side multiplied by corresponding altitude. Similarly, if there is a parallelogram and a triangle on the same base and between the same parallels, then area of triangle will be half of the area of the parallelogram, and the area of triangle will be 1 upon 2 base into height, or 1 upon 2 into side into corresponding altitude. Again over here, if we are saying that there are two parallelograms are there, this is one of the parallelogram and this is another parallelogram. One parallelogram is ABCD, another is here EFD. These two are the parallelograms on the same base and between the same parallels, so their area will be equal. So if there are two parallelograms are there which are on the same base and are having the same area, then automatically we can conclude that they are lying between the same parallels. If the two parallelograms are on the same base between the same parallels, we say that their areas are equal. But along with that, if there are two parallelograms which are on the same base and are having the same area, then they are going to lie between the same parallels also. Now let's understand some of the questions from your exercise 9.2. Question number 1 we are taking. In figure 9.15, first of all I am making the figure. This is the figure. It is A, B, C and D. It is E and it is F. ABCD is a parallelogram. AE is perpendicular to DC and CF is perpendicular to AD. AB is given to us as 16 centimeter. AE is given to us as 8 centimeter. And CF is given equivalent to your 10 centimeter. We have to find the value of AD. Now just now we have seen that the area of the parallelogram is base into height, or we can say one of the side we will be considering and corresponding altitude we will be considering. So area of parallelogram ABCD is equivalent to, if I am going to consider this DC as the base, DC as one of the side we are considering, then in that case corresponding height will be your AE. For DC side, AE will be the corresponding height. So it will be side multiplied by corresponding height, that is your AE. And if I'll be considering this as the base, AD as the base, AD as the side, then the corresponding height, corresponding altitude will be your CF. So AD multiplied by your CF. In both the cases, because it is the same parallelogram, in both the cases your value will be same, that will be area of parallelogram ABCD. If I'll be considering this as the side, then AE will be the corresponding altitude. If I'll be considering AD as the side, then CF will be the corresponding altitude. Now we'll be keeping the values. DC is perpendicular to your AE. All these are given to us. Now DC is even equivalent to your AB. These are the opposite sides of the parallelogram. DC and AB will be equal. So instead of DC we can write AB also. Value of AE we are having. AD we have to find, and CF is already given. See, AB and CD are the opposite sides of a parallelogram, and we know that in a parallelogram opposite sides are even equal. So AB could be written as your 16. AE is 8, AD we have to find, so we will keep it as it is, and CF is your 10. If we will be solving it further, 16 multiplied by 8 is equivalent to, divided by 10 is equivalent to AD. 2 5 is 10, 2 4, then 16 4 is 64, divided by 5. So AD will be your 5 1 is 5, 5 2s are 10. 12.8 centimeter will be your AD. The length AD will be your 12.8 centimeter. This is how we can find it out. Area of parallelogram is whatsoever the side you will be considering, accordingly corresponding altitude you will be considering. From both the two ways, we have find the area of a parallelogram and then equated it. So this will give you the value of the side AD. Now let's see the question number 3. P and Q are any two points lying on the side DC and AD respectively of a parallelogram ABCD. First of all, we will make a parallelogram ABCD, A, B, C and D. Then P and Q are lying on DC. DC, over here it is P is there somewhere, and Q is lying on AD. Q is lying over here. Respectively of parallelogram, show that we have to prove that area of APB is equivalent to area of BQC. This we have to prove it. Now let's see how we can solve it. First of all, what we will be doing it, this is the point given to us and this is even the point given to us. We can join these 2 points like this. And similarly, we can join this also. Right? So what we had done is, there is a point Q on the side AD and there is a point P on the side DC, it is given to us. Right? Now, if we are going to consider the triangle ABP, we are considering the triangle ABP. Triangle ABP and parallelogram ABCD are on the same base, that is your AB, and between same parallels. Between same parallels AB and CD. These two triangle ABP and parallelogram ABCD are on the same base AB and between the same parallels AB and CD. That's the reason area of triangle ABP will be half of area of ABCD. Just now we have said that area of a triangle is half of the area of the parallelogram if they both lie on the same base and between the same parallels. Now we will be considering triangle BQC. we will be considering triangle BQC. If we are going to see triangle BQC and the parallelogram ABCD are on the same base is there, that is your BC. They both are on the same base BC. We are considering triangle BQC and parallelogram ABCD. They both are on the same base BC and between same parallels, that is BC and AD. So if there is a triangle and a parallelogram which are on the same base and between the same parallels, then area of triangle BQC will be half of area of parallelogram, that is ABCD. This is equation number 1. This is equation number 2. Both the equation number 1 and equation number 2 right hand side is equal. Half of area of ABCD. So what we can conclude is area of ABP is equivalent to area of BQC, and that was to be proved. So this is how we can prove it. Now let's understand some more theorems. Theorem 9.2, which is based on triangles on the same base and between the same parallels. Till now we have seen parallelograms on the same base and between the same parallels, one of the triangle and one of the parallelogram on the same base and between the same parallels. Now we'll be considering two triangles on the same base and between the same parallels. So theorem says that if there are two triangles on the same base or equal base and between the same parallels, then their area will be equal. How we can prove it? Suppose there is a triangle ABC and another triangle we have taken PBC. These two triangles we have taken on the same base BC and between the same parallels BC and your AF. Now we have to prove that the area of ABC, will be equivalent to area of your PBC. This we need to prove it. Now how we can do it? For that we will be just making some construction. We will be making a line CE which will be parallel to your AB. Construction will be, we will be making a line CE parallel to your AB. This line CE is going to touch your line AF. This line which we have taken, it is going to intersect the line at this point, and this point will be your E. Similarly, from the point C, we will be making a line parallel to your BP. We will be making a line parallel to BP starting from C, which is going to intersect this line at point F. So BP will be parallel to your CF. Now we can see over here ABCE is one of the parallelogram and BPFC is another parallelogram on the same base and between the same parallels BC and your AF. Two parallelograms are there. One is your ABCE because we have constructed this CE parallel to your AB, and already your AE was parallel to your BC, and when both the pair of opposite sides is parallel, we say the quadrilateral to be a parallelogram. So that's the reason ABCE is one of the parallelogram and BPFC is another parallelogram. And we have just now seen that if there are two parallelograms on the same base and between the same parallels, then their areas are equal. So area of parallelogram ABCE will be equivalent to area of parallelogram BPFC. These two areas will be equal because these two parallelograms are on the same base BC and between the same parallels BC and AF. Now we can see in the parallelogram ABCE, AC is the diagonal, and diagonal of a parallelogram bisects the parallelogram into two congruent triangles. That means ABC and ACE will be your two congruent triangles. And just now we have said that if there are two figures which are congruent, then their areas will even be equal. So over here triangle ABC is congruent to triangle ACE. These two triangles will be congruent because the diagonal of a parallelogram divides it into two congruent triangles. So we can say triangle ABC area of this triangle will be equivalent to area of the triangle ACE. Because if two figures are congruent, then their areas are even equal. So area of both of them will be equal. Now similarly, we are going to consider the parallelogram BPFC. This BPFC, in this PC is the diagonal, and this PC diagonal is going to divide this parallelogram into two congruent triangles. That's the reason area of triangle, your triangle PBC will be congruent to triangle PCF. And because these two triangles are congruent, so their areas will even be equal. So area of triangle PBC will be equivalent to area of triangle your PCF. These two areas will be equal. Just now we have said that area of ABCE is equivalent to area of your BPFC. So if their area are equal, so half of their area will even be equal. Half of ABCE will be equivalent to half of area of BPFC also. And we know that if there are one parallelogram and one triangle on the same base and between the same parallels, then their areas are even. Area of if there are two parallelograms on the same base and between the same parallels, then their areas are equal. And if there is a parallelogram and a triangle on the same base and between the same parallels, then the area of the triangle is half of your area of your parallelogram. So half of the area of parallelogram ABCE will be your area of ABC, because we know that area of triangle ABC will be half of area of ABCE, because these two, your triangle and the parallelogram, are on the same base and between the same parallels. That's the reason area of triangle ABC will be half of area of triangle ABCE. Similarly, your area of triangle PBC, area of triangle PBC will be half of area of your parallelogram, half of area of parallelogram BPFC, because the area of the triangle is half of the area of the parallelogram if they are on the same base and between the same parallels. So half of ABCE could be written as area of your ABC, and half of BPFC could be written as area of your PBC. And this was to be proved that if there are two triangles on the same base and between the same parallels, then their areas are equal. So this is how we can prove it. First of all, we will be making the parallel lines and convert these triangles to be parallelograms. And then whatsoever the properties till now we have studied, that if there are two parallelograms on the same base and between the same parallels, their area will be equal. And if there is a triangle and a parallelogram on the same base and between the same parallels, then the area of the triangle will be half of the area of the parallelogram. So this is how we can prove it. So what we can say is one more thing. If over here it is written that if there are two triangles on the same base and between the same parallels, then their areas are equal. Now if there are two triangles on the same base and whose areas are equal, then we will say then these two triangles are on the same, between the same parallels also. See, this is your theorem number 9.3, that if there are two triangles having the same base, they are having the same base, means they are having equal bases and equal areas, equal area also they are having, then they will be lying between the same parallels. So we have learned just now that the area of parallelogram was your one of the side we will be taking and corresponding altitude we were taking or height we were taking, or we can say base into height, any of the side which will be taken as base, and then accordingly we'll be taking height, and area of triangle will be 1/2 into base into height, or we can say 1/2 any of the side we will be considering, and accordingly for that side corresponding altitude we will be considering. So these are the areas of parallelogram and area of triangle. So if there will be two triangles having the same base and equal areas they will be having, then they are going to lie between the same parallels also. Now let's understand some more concepts related to area of a triangle. The median of a triangle divides it into two triangles of equal areas. So first of all, what median is, if from a vertex A we are going to draw median on the side BC, then suppose it is going to intersect the side BC at point D, then this D point is going to bisect the side BC. That means median bisects the opposite side. If from the vertex A we are going to draw the median on the side BC, then it is going to bisect the side BC. That means BD will be equivalent to your DC. BD will be equivalent to DC. Now AD is the median in the triangle ABC. So this median is going to divide this triangle into two parts, two triangles, and the area of these two triangles will be equal. That means area of triangle ABD will be equivalent to area of triangle ADC. These two areas will be equal. This we need to prove. So just now we have seen that area of triangle, any of the triangle, it is equivalent to your 1/2 into side into corresponding altitude. Either we can say this or we can say 1/2 into base into height. Any of these formulas we can use. So if we will be taking ABD triangle in which we have made an altitude, we have drawn a perpendicular on the side BC from the vertex A, that is your AT. This is the altitude on the side BC. Now area of triangle ABD. ABD will be 1/2 into base. Base is over here, it is BD. It is your BD and the corresponding altitude is your AT. This is the area of this triangle ABD. Similarly, if we are going to consider area of triangle ADC, it will be 1/2 into base over here is your DC. Base is your DC and corresponding height is your AT only. This will be the corresponding height. So this is your AT. Now, if we are going to see over here, this is already given to us. This is equation number 2 and say this is equation number 3. So from equation number 1, BD is equivalent to DC. So instead of BD, we can write DC, or instead of DC, we can write BC also, BD also. So over here, we are replacing DC by your BD. So from equation number 2 and equation number 4, what we can say is that area of triangle ABD is equivalent to area of triangle ADC, because it is also 1/2 into BD into AT and it is also 1/2 into BD into AT. So we can say that the median of a triangle divides it into two triangles of equal areas. Area of triangle ABD is equivalent to area of triangle ADC, because both are equal only. BD was equivalent to your DC. So we can say it is going to, median is going to divide the triangle into two triangles of equal areas. Now let's understand some of the questions from your exercise 9.3. First of all, we are taking question number 1. In the figure 9.23, first of all, I am making the figure. This is the figure here. It is your point A, it is your point B, it is C, it is D, and it is E. E is any point on median AD. AD is median. It is given to us that AD is median. Of triangle ABC, we have to prove that area of ABE is equivalent to area of ACE. We need to prove that area of ABE, this area, is equivalent to ACE, this area. This we need to prove. Over here it is given to you is AD is the median of the triangle. That means D is the midpoint of BC. That simply means BD is equivalent to your DC. Now just now we have seen that the median of a triangle divides it into two triangles of equal area. Now in the triangle ABC, AD is the median, so that's the reason area of triangle ABD will be equivalent to area of triangle ADC, right? Just now we have seen that median is dividing the triangle into two triangles of equal areas. So this is the median. So area of the triangle ABD will be equivalent to area of triangle ADC. This is, we have considered triangle ABC. Now we are considering triangle EBC. EBC triangle we will be considering. Again we can see D is the midpoint of BC. That means ED is also median for this triangle EBC also. So if ED is the median of triangle EBC, so it is dividing the triangle into two triangles of equal area. So we can say area of triangle EBD will be equivalent to area of triangle EDC. Because for this triangle EBC, ED is the median as D is the midpoint of BC. That's the reason this median will divide this triangle EBC into two triangles of equal area. So area of this triangle will be equivalent to area of this triangle. Now if from the equation number 1, we will be subtracting equation number 2. Equation number 1 minus equation number 2 if we will be doing. So area of ABD minus area of EBD will be equivalent to area of ADC minus area of EDC. Now from the area ABD, this whole area, if we will be subtracting area of EBD, what the area we will be getting? We will be getting area ABE. So it will be area ABE, and from the area ADC, if we will be subtracting area of EDC, this area if we will be subtracting, we will be getting area AEC. So it is equivalent to area AEC, and this was to be proved. So this is how we can prove it using this theorem, this property. Now the next question is your question number 4. In the given figure, first of all I am making the figure. This is how this figure is. It is A, D, B, this is C, this is O. In the figure, ABC and ABD are two triangles on the same base AB. If line segment CD is bisected by AB, that means your OC is equivalent to OD, because AD is bisecting your CD. So we will see that OC is equivalent to your OD at O. Then show that to prove. What we need to prove is area of ABC is equivalent to area of ABD. This we need to prove. We need to prove that area of ABC, this part, this area is equivalent to area of this part, ABD. Now what we can do is, for proving this, simply over here it is given that this part is equivalent to your this part. OC is equivalent to OD, it is given to us. So first of all, we will be considering the triangle BCD. We will be considering the triangle BCD. This triangle we will be considering. Now O is the midpoint of CD. It is given to us that O is the midpoint of CD. That means BO is the median of the triangle BCD. BO is the median of the triangle your BCD, and if it is a median, then it is going to divide the triangle BCD into two triangles of equal area. That means area of triangle BCO will be equivalent to area of triangle BOD. Because O is the midpoint of CD, that means BO is the median, and we know that the median of a triangle divides it into two triangles of equal area. So area of BCO will be equivalent to BOD. These two areas will be equal. Now we will be considering, suppose this is equation number 1. we will be considering the triangle CAD. This triangle we will be considering. Again, O is the midpoint of your CD. That means AO is the median of the triangle CAD. AO is the median of triangle your CAD, as O is the midpoint of CD. And we know that the median divides the triangle into two triangles of equal area. That means area of triangle CAO will be equivalent to area of triangle DAO. This will be equal. Now, if we will be adding equation number 1 and equation number 2, equation 1 plus equation 2, then we will be getting area of BCO plus area of CAD, CAO. It is equivalent to area of BOD plus area of DAO. Now area BCO, this area plus CAO, this area. If we will be adding this area and this area, we will be getting area of your BCA, or we can say ABC, area of triangle ABC will be getting. Therefore, area of triangle ABC is equivalent to BOD, this area, plus DAO, this area. If this area plus this area we will be adding, we will be getting area of ABD. It is equivalent to area of ABD. And this was to be proved. So this is how, using the concepts of your median of a triangle divided into two triangles of equal area, we can solve so many questions of the exercise. This is all from this chapter. Hope it is clear to you. What is parallelograms area? What is triangles area? What is the relation between if the two figures are on the same base and between the same parallels? Soon we'll be coming with the more videos on the next chapters of class 9th maths curriculum. Thank you.